All right, so I think I finally got the hang of this video and whiteboard. And so I wanted to log in today and do a few examples from some of the first sections in the first unit so that you guys have some stuff to go by other than just the videos in Blackboard learning units and the learn part of POCs. So I was going to just start at the beginning and work a few examples kind of in order for the sections. And my plan is to make a video today, make another one tomorrow, and then make one on Thursday as well to try to cover some of this content. I know that we got pushed back quite a bit with the imaginary storm, but I'm going to try to get us caught up here for this first unit and then try to be more consistent along the way here with the rest of the content for the semester. So we'll see how this goes, and hopefully these videos are beneficial for you guys, and that way you have at least a little bit more guidance than you've had so far. So I wanted to start with section 1.5, which is these linear equations. And I'm going to start with one that's a little bit involved, but still doesn't have any fraction stuff in it. And then we'll get into some fraction things as well so that you guys can see the way to work a fraction problem. So let's say we had something like 5 times 3x plus 2 minus 4 equals 6 times 2x minus 1, or something like that. So this involves most of the steps that are required for equation solving except for the fractions. So I'm going to kind of walk through each one of these steps. So we would start with distribution to remove the parentheses, and we're going to do that on both sides. So 5 times 3x, 15x. 5 times 2 is 10. And then that minus 4 is still kind of just hanging out on the outside there, and we'll put it in when we combine like terms in the next step. On the other side, we're going to do the same thing. We're going to distribute. 6 times 2x gives me 12x. 6 times negative 1 is negative 6. So now we've got everything kind of multiplied out. From here, we want to go through and simplify each side separately if it's possible. So I'm going to combine the like terms over here. And when you combine like terms on the same side of the equation, you do not use opposite operations. So opposite operations are only going to be used when you combine like terms on opposite sides when you're moving from one side to the other. So we're going to combine a 10 and a minus 4 as they are, which is going to give me a positive 6. And on the other side, we don't have any like terms to combine. So we're going to just leave it. Now, once we combine the like terms, now we're going to start moving things from one side to the other so that we can get this thing into a better form to solve. We're trying to isolate our variable, and in order to do that, the variables have to be on the same side. So we get to decide which side we want to move it from, whether we're going to move the 15x or the 12x. It's really a personal choice. I typically move my variables in equations whichever direction is going to keep it positive, though it does not matter because whichever side you decide to put it on, it will work out the same way as long as you do your math right. So I would move the 12x. I'm going to subtract 12x over, and I'm putting it underneath the 15x because that's the like terms. So 15x minus 12x is going to give me 3x, and we still have plus 6 here. But on the other side, the x's have canceled, and now we have a negative 6. From here, this is what I call a two-step equation, meaning there are two numbers on the same side as the x, and we're going to move them both over. So I'm going to start with minus 6 and combining, which is going to give me 3x equals negative 12. And then to get the x by itself, we divide both sides by 3. Divide 3, divide 3, we get x equals negative 4. So there you go. Now, I want to look at a couple equations that contain fractions, and they're going to contain fractions in different ways. So the first one is going to have all these separate terms that some are fractions and some are not, and the second one is going to be rational type expressions where the denominator is a value. So let's say that we had something like 3/2 x plus 4 equals 1/3 x minus, I don't know, 3/4. Now, the best way to handle a problem like this is to not work with the fractions at all. However, if you're comfortable with fractions, you are welcome to work with them as they are. I would like to get rid of all of these fractions. So the best way to do that is to find the least common denominator for all of them and then multiply every term in this expression by that LCD. So LCD has to be found. We're comparing the 2 and the 3 and the 4 denominator. So the least common multiple between 2 and 3 and 4 is 12, which means I'm going to take each one of these terms and multiply it by a 12. And I typically put it over 1 when it's a fraction because that way we keep it consistent. If it's not a fraction, I'm just going to put it next to it. All right, so each one of these got its own 12. And now I'm going to use the 12 to cross cancel my denominators. 12 cancels the 2, but there's 6 left over now times that 3x. In the second term, we don't have a denominator, so we're just going to multiply. So 12 times 4 gives me 48. On the other side, the 12 cancels the 3. I'm left with 4 here, so 4 times 1x. And minus 12 cancels the 4, but there's 3 left, so 3 times 3 here. Now, all of these terms can be simplified, but the point is the denominator's gone. So now this first term here becomes 18x plus 48. This term here, 4 times 1x is 4x. And then minus 3 times 3 is minus 9. So here's my new equation. So we've got this nice, neat new equation that instead of having all of these nasty fractions in it, it now has nice, neat, perfect little integers to work with. And from here, we can go through and solve it the same way that we solved the one from the last example, because now it's just integers. There's no like terms to combine. Everything's kind of in simplest form. So I'm going to start moving things from one side to the other. Again, I like to keep my variables positive. So I'm going to move the 4x over to the left. And that's going to give me 14x plus 48 equals -9. And now once again, I'm in a situation where I have a two-step equation. So 2 things to move. Minus 48, which is going to give me 14x equals -57. I think -9 minus 48. Just want to double check so I don't mess this up. Yep, -57. And now I have to divide both sides by 14. So -57 divided by 14 is going to give me, I wanted to check and see if it's simplified. It doesn't. -57 over 14. Now, if Hawks will allow your answer to be in decimal form, you are welcome to change these to decimals. However, I wouldn't do it unless you were absolutely sure that Hawks is fine with a decimal answer. A lot of times they want a fraction answer, so most of the time I just leave it as a fraction. So this is your final answer. So that's the first type of fraction equation that you might see. The second type of fraction equation that I noticed that Hawks is including here is fraction equations that kind of look like they have rational expressions in them. So something more like 2x plus 4 over 5 equals 3x minus 1 over 2. So now we have these two expressions in the numerator and then a single denominator. They're still solved the same way. So even though we've got these weird looking expressions, we're still going to use the LCD to get rid of the denominator entirely and then just simplify what's left. So the LCD between 5 and 2 is 10, which means I'm going to put a 10 over 1 in front of both sides of this thing. Now the same thing is going to happen that happened the last time. Your numerator is going to cancel the denominator and there's going to be a little something left. So on the left-hand side, there's 2 left to go with the 2x plus 4. Notice that I put the numerator in parentheses, and that's because we're going to be distributing that coefficient into the entire expression that's left in the numerator. So it's not just going to go with the first piece, it's going to go with the whole thing. On the other side, 10 cancels the 2, I'm left with 5, and then 3x minus 1 is left on top. Now this new equation looks kind of similar to the first one that we did in that we now have some parentheses that we have to deal with. But again, when we have our parentheses, we're just going to distribute. 2 times 2x is 4x. 2 times 4 is 8. On the other side, 5 times 3 is 15x. 5 times negative 1 is negative 5. Now from here, I want to get my variables on the same side. I like my variables positive, so I'm going to subtract 4x over. That's a 4, even though it doesn't look like one. This gives me 8 equals, what is that, 11x minus 5. And now again, I've got these two numbers that I have to move. I'm going to add the 5 over, which is going to give me a 13 over here equals 11x. So again, I'm going to get an ugly fraction, but that's okay. Divide both sides by 11. So we get 13 over 11 as our final answer. And again, I'm just going to leave it as a fraction because I think that's the safest bet. So this kind of gives a good overview of the regular linear equations in one variable. Now this section also gets into another type of equation, which is absolute value equations. And the absolute value equation stuff is going to come in handy because we're going to have to do it again in absolute value inequalities. So we're going to take a look at that. And this is, I wonder if I can type in here and make it look nice. Oh yeah, it's purple, but we'll get the hang of this. So for absolute value equations, you're going to have an absolute value expression inside your equation. So there are steps to solve absolute value equations, and they're very important to make sure that we follow the steps kind of like exactly. Let me see if I change this to black now. Oh, I did. Okay, so steps for solving. This is important because we want to make sure that we follow our steps and make sure that we do each one in order. So first step is always, 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 always isolate the absolute value. You have to get the absolute value all by itself. Isolation is the most important step that you have because if you don't do it, you will not get the right answer. There is no way to get the right answer. You'll get half of it right and the other half wrong. So we want to make sure that we isolate the absolute value. Once it's isolated, we are going to create two equations using the expression and the number on the other side. Now, the equations are going to look very similar, but have kind of like one major difference. So the first equation takes the expression and sets equal to the number, whatever the number is. Second equation takes the same expression and sets equal to negative of the number. Then we're going to solve. Now, important note, and this is a very important note. Important, important, important. If you isolate the absolute value and the number on the other side is negative already, like off the bat, before you split, absolute value equal to a negative, then you don't even have to solve this thing. The answer is no solution. So you can stop. You don't even have to do any more. The answer is no solution, and that's that. So the only time that can possibly happen is if you isolate and you have a negative on the other side. If it's positive, you can solve this thing just fine. So I want to take a look at one of these so that you can kind of see what I'm talking about here. And I'll do a kind of a basic one here. So here's my first one. We'll say absolute value x plus 2 minus 5 equals 3. Now notice that there's a number over there on the same side as the absolute value, which is going to cause a problem. So the first thing we want to do is isolate, because the isolation is the most important part. To isolate, I'm going to add this 5 over to the other side. So adding the 5 over gets my absolute value all alone. And then it's set equal to an 8. Now, 8 is positive, so we're not going to have a no solution situation. We're going to actually split this thing and create our two equations. Now, the first equation takes the expression under the in the absolute value, x plus 2, and sets it equal to the number like it is. The second equation takes the same expression, x plus 2, and sets it equal to negative of the number, in this case 8. These two equations are going to be the two equations that we solve to get our final solution here. So we have to solve them using opposite operations just like we did before. So we're going to subtract 2, that's a 3, subtract 2, and we get x equals 6. On this side, we do the same thing, minus 2, except we get x equals negative 10. Now, absolute values are going to have two solutions, which is fine. You're going to get two answers. The only time that you wouldn't get two answers is if we have a no solution situation, or if your absolute value is set equal to 0. Because if you have an absolute value set equal to 0, there's no way to take a positive and a negative because 0 is just 0. So this is what the absolute values are going to look like. And I want to take a look at a couple more absolute values. And then I think this should be good for the equation stuff. So let's get rid of this. I want to look at one that a lot of people tend to get confused. So let's look at this. So it's going to look like 4 absolute value x minus 1 equals, we'll do 12. Now, a lot of people mistake a 4 being directly in front of this as addition and then try to subtract the 4 over. If there is no operator separating your number from your absolute value, it's understood that the multiplication symbol is in there. So you're actually multiplying 4 in this case. Since this is an absolute value, we're not going to actually multiply 4 like we would if it was a parenthesis. We're going to get rid of it because we're supposed to isolate. So we're going to divide that 4 out. So the 4's cancel. I've got absolute value x minus 1 equals 3. And now here, my absolute, this is an equals, not a negative, equals 3. Now my absolute value is isolated, so I can do my split. So my first equation looks exactly the same. X minus 1 equals 3. Second equation, same expression, x minus 1, except on the other side, we've got a negative 3. These become my two equations that we're solving. And again, they're pretty basic equations, so all I'm going to do is add 1, and I get x equals 4. Add 1, I get x equals negative 2. So there's my two answers. And you can always check these answers by plugging them back in and making sure that they work and they make sense in the context of the question. The last one of these that I want to look at is an absolute value that involves two different absolute value symbols. So something like absolute value 4x plus 2 minus absolute value x minus 5 equals 0. Now, this is different from the last one because the last one had a single absolute value instead of two. So there was a possibility of isolating an absolute value and getting it all by itself and a number on the other side. In this case, we're not going to be able to isolate our absolute value altogether because there's two of them. So instead of isolating an absolute value, we're going to put one on each side. So to do that, I'm going to add the second one over. So that looks a little bit weird, but all we're really doing is just taking it and transferring it over. So it's going to look like absolute value 4x plus 2 equals absolute value x. Oh, it's minus 5. Minus 5. So now we've got one on each side. Now, from here, we can still do the same kind of splitting and creating two equations. And we follow sort of the same type of rule. You leave the expression in the first one alone. When you create your equations, the first time you leave the second expression alone as well. But the second time, the signs in the second expression are going to change. Now, to make this a little bit more clear, let's take a look. We've got 4x plus 2 equals, leave the signs alone, x minus 5. For the second equation, 4x plus 2, so same expression, equals, now we're going to change the signs. Instead of positive x, we're going to have negative x. And instead of negative 5, we're going to have positive 5. So same, opposites on the other side. Now that it is split into our two different equations, we can solve using the same linear equation methods that we used at the beginning with the basic equations. So I'm going to get my variables on the same side. In this case, I'm subtracting x over. I get 3x plus 2 equals negative 5. Now I'm going to subtract 2. I get 3x equals negative, that's a negative, so negative 7. And then when I divide both sides by 3, x equals negative 7/3. So there's my first solution right here. Now we're going to find the second one using the same methods. This time I have to add the x over because it was negative. It's going to become positive with the opposite. This is 5x plus 2 equals positive 5 now. And so when I do my opposites this time, I'm going to be subtracting 2 from a positive 5, which is going to change what's over there. We now have 5x equals 3. So when I divide both sides by 5, I get x equals 3/5. So we've got a negative 7/3 and a positive 3/5 for my two answers. Typically, when you put these answers into the Hawk system, you're going to put them in as two separate answers separated by a comma. We don't put parentheses or anything around them. That's only used in ordered pairs and interval notation. So we want to make sure we just keep them kind of separated with a comma and that's it. So this is the linear equation stuff covered in section 1.5. In the next video, I will talk about linear inequalities. So we'll go through basics and compound and the absolute value ones, how to graph them, how to create the interval. And then after that, we'll get into some factoring. So I'm going to do several examples in both of those sections, so the videos might be a little bit longer. This was just kind of an overview of linear equations and to kind of see how the video thing is going to work. So hopefully, like I said at the beginning, that this will be helpful and you guys will have some extra um, aid in these sections because you don't have an actual in-seat lecture. So hopefully this will help. And if you have any questions, as always, you can email me and I will try to respond as promptly as possible. So thank you so much.